Hello viewers, question 5. Walter the water lover descends down a water slide of height 40 metres. Walter has a mass of 77 kilograms. Part A of the question is to determine Walter's potential energy at the top of the slide. So we've got EP equals potential energy is mass times gravity times height. The mass is 77, gravity is 9.81, and the height here is 40 metres. And if we calculate that, we get 30,214.8 joules, which is approximately 30.2 kilojoules. Okay, so question B, what is the maximum kinetic energy that Walter can have at the bottom of the slide? So we're assuming that at the top of the slide he is stationary, and therefore at that point his kinetic energy is 0. Therefore, as he goes down the water slide, all of that potential energy he has at the top gets converted into kinetic energy at the bottom, and therefore the maximum amount of kinetic energy he has at the bottom is the same as the amount of potential energy he has at the top, namely 30,214.8 joules, which, as we said before, is 30.2 kilojoules. And question C, what is the maximum speed that Walter can have at the bottom of the slide? So we know already that the maximum kinetic energy that he can have is 30,214.8 joules. The maximum speed will be the speed at which his kinetic energy is that much. So the kinetic energy is 1/2 mv squared, and we want to solve that for v because we want to find the speed. If we multiply that through by 2, we get 2ek equals mv squared. Let's divide that through by m, so we get 2ek over m equals v squared, and if we take the square root of that, we get square root of 2ek over m equals v. So v is the square root of 2 times kinetic energy, which is 30,214.8, and we're dividing that by Walter's mass of 77 kilograms. Calculating that gives us 28.0 metres per second. Question D, because of friction, Walter actually reaches the bottom at the speed of 19 metres per second. Determine the work done by friction on Walter. So he actually loses some of that kinetic energy so that he only reaches the bottom at 19 metres per second. So the actual amount of kinetic energy he has at the bottom would be the same as the amount of potential energy he has at the top, minus he's lost some energy. Let's call that delta E, the change in energy, and that amount of energy lost is also the work done by friction, which is what we want to find in this part of the question. So if we add W to both sides and we subtract the kinetic energy at the bottom, we get the work done is the potential energy at the top minus the kinetic energy at the bottom. So the potential energy he has at the top we already know to be 30,214.8, and the kinetic energy he has at the bottom is 1/2 mv squared, with m is 77 and the actual speed at the bottom is 19, 1/2 mv squared, so we need to square that and we get 16,316 joules. Okay, so we've got the amount of work done. Now we need to find the force due to friction. So the relationship between work and the force is W equals Fd, but we need to be careful about the value of D that we use here because that will not be 40 metres. So we're given that the slide is inclined at 30 degrees. So we've got a 30-degree angle relative to the horizontal. We know that the height is 40 metres, and the actual length of the water slide will be the hypotenuse of that triangle, D. So we've got the opposite side as 40, hypotenuse is D. Dealing with opposite and hypotenuse, so we're dealing with sine. So sine of 30 is equal to 40 over D, and therefore D is 40 over sine 30. Calculating that, we get length of the slide is 80 metres. So that will be the value of D we use in work equals force times distance. Force is therefore work divided by distance, which is 16,316, divided by distance is 80, and we get a value of 204 newtons as the force due to friction. And then question F, determine the coefficient of friction between Walter and the water slide. So the force due to friction is mu, which is coefficient of friction, what we want to find here, multiplied by the normal force. And for an incline, the normal force is mass times gravity times cosine of the angle, so that is going to be 77 times 9.81 cosine of 30, and that works out to be 654.2. Then we can rearrange our friction formula for mu, which is force due to friction divided by the normal force, which is force due to friction we found to be 204, and we're dividing by the normal force, which we've just found to be 654.2. Calculating that gives us a value of 0.312 as our coefficient of friction. Okay, thanks for watching. Over and out.